Hi students, we are going to start new chapter Profiles and Profiles View. Profile information is the backbone of vertical design. The AutoCAD Civil 3D software takes advantages of sample data, design data, and external input files to create for a number of uses. Profile views will be an integral part of Corridor, as we will discuss in the next in the chapter for Corridor. In this chapter, we will look at using profile creation tools, editing profiles, and generating and editing profile views. We will also apply labels like we did in the previous chapter for alignment. So our goal will be in this chapter: sample a surface profiles with offset samples, layout a design profiles on the basis of table data, add and modify individual entities in our design profile, and apply a standard band set. The whole point of building a three-dimensional model is to include the elevation element that's been missing for years on two-dimensional plans, but to get there, designer and engineers still depend on the flat 2D representation of the vertical dimension, same like our profile view of Civil 3D. So a profile is nothing more than a series of data appears in a station elevation format. There are basic curves and tangent components, but these are purely the mathematically basis for the paired data set. In AutoCAD Civil 3D, we can generate profiles information in 5 ways. The first one, if we talk about, if you can see here, we have create surface profiles, profile creation tools, create best profiles. So we can define them in a 5 best way of the creation of the profile views. The first one, sample from a surface. Sampling from a surface involves taking vertical information from a surface object every time the sample alignment crosses a TIN lines of the surface. This is actually perfect for generating a profile for the existing ground. The next one, using a layout to create a profiles. It's a profile which allows you to input design information, settings, critical installation and elevation points, calculating curves to connect linear segment, and typically working within design requirement laid out by reviewing agency. So we use this method for design profiles. Then we have creating best fit profiles, similar to the ability to generate a best fit alignment that we already discussed in the previous chapter. If you did not look at there, just go back in the previous chapter and you can learn how can we create alignment, best fit alignment. And we can also create a best fit profile, same like this. We may find yourself method when you are trying to generate defined geometry for an existing road. So the next method is creating a profile from a file. It will let you reference a specially formatted text file to pull in the station and elevation pairs. Doing so can be helpful in dealing with other analysis packages or spreadsheet tabular data. So it's very useful tool in Civil 3D which we can use to create profile. Then we have create superimposed profiles. We can project a profile based on another alignment into profile views. This can be done for comparison. For the label sets can be applied to superimposed file. For example, we have center line and offset alignment, so we can superimpose them in a one profile view, and then we can take a look to compare them, how they are going up and down with each other. Then the last method, creating a profile from a corridor. We can define a profile by using a corridor feature line as the source for its definition. This can't be helpful for times when we want to display the profile of the flow line of the curve in the same profile view with the center line, for example. So we have 5 methods, and in this chapter we will practice with all of them. So stay tuned with us for the next hands-on exercise with practical drawings